So the question tells us the mass of the cyclist bike is 75 kilograms, so let's write that down. The speed is 8 meters per second. What is the kinetic energy? EK equals what? Well, we've got a formula that relates all of that from the formula sheet. EK equals a half mv squared. So let's put all of that in. Put that in your calculator. Again, you might want to have 0.5 instead of 1 over 2 times 75 times 8 squared equals 2,400 joules. The maximum height of the jump above point X. Well, all this kinetic energy that they have down here is going to be converted into potential energy when you go up the way. So all of this kinetic energy becomes potential energy. So our potential energy would be just that, 2,400 joules. The mass is 75 kilograms, just the same. And what else do we need for that? Well, we want to work out the height, and then we know that our gravitational field strength is 9.8. Let's put it into the formula. EP equals mgh. So we've got 2,400 equals what? 75 times 9.8 times the height, which we don't know. Height is, well, all this is multiplying, so it then divides when it goes over the other side. Our height is, well, it's 2,400 divided by, and then let's keep that in brackets, 75 times 9.8, make sure it's all on the bottom, press equals 3.26. But again, we've only got two significant figures here, so it would be 3.3 meters, our final answer. Explain why the actual height in the jump above point X would be less than the height calculated in B. Well, it's because there's some energy which is lost. Not all of that kinetic energy is going to become potential energy. Some of it might be lost due to friction. There's going to be air resistance, so a bit of heat energy. Some of it might be lost due to sound. The bike might make some noise when it's going up the ramp. Lots of different things you could say. But yeah, the important thing is energy is lost due to, we'll say air resistance is the main one. Explain why. Well, that's a reason, because energy is lost due to air resistance. Got a guy who's jumping off a ledge while on his bike. Again, he's going at a constant speed over this way, and he's falling vertically, accelerating that way. So you need a nice curve. So I guess if we were to go sort of from the bottom here, it's going to immediately start curving, getting steeper and steeper and steeper, down like that. He never goes up, it moves horizontally. After 4 seconds, calculate the vertical velocity of the cyclist and bike as they reach the ground, and you can ignore air resistance. Well, if we can ignore air resistance, we know that the acceleration is 9.8. We know his initial vertical speed is 0. We want to work out his final speed. Time is 0.4 seconds. Let's put all that in the formula. So 9.8 equals what? Well, the final speed, take away the initial, divided by the time, which is 0.4. Again, take away 0 doesn't really mean anything, so let's make it easier to deal with. 9.8 equals v over 0.4. It's dividing by 0.4, so it needs to multiply on the other side. Put that all together in your calculator. 9.8 times 0.4 is 3.92. We've only got two significant figures in the data, so we'll give it as 3.9 meters per second.